Okay, so how do you determine a molecular formula? Last chapter we showed you how to determine empirical formulas, but how do we do molecular formulas? Well, there are two things that you need to find out a molecular formula. Number one is the empirical formula. You need the empirical formula. And number two is the molar mass of your compound, the molar mass. So these are the two things you need, empirical formula and molar mass. Last section, I taught you how to find this. All right, you convert the percentages into grams, you divide them by the atomic mass, you get the mole ratios, you divide by the smallest number, yada, yada, yada. In this case, you now have to find the molar mass, okay? And what you're gonna do, it's this formula, you take the molar mass, whatever your molar mass is, this number, and divide it by the mass of your empirical formula. Because your empirical formula is gonna be smaller and you're gonna find some sort of ratio. And that's what you need to multiply by, okay? It might be confusing right now, but when I show you, it's actually pretty straightforward, okay? So here's an example. You remember the first example we did? We found out it was a C1H1, the last example, okay? The last example, we found out it was C1H1. Let me see if I can go back to remind you of the problem we did. This one right here. Right, it's the first problem, 92.26 grams of this, 7.743 grams of this. We did it, we came out with CH. Remember I said, I don't know what these numbers are. They can be 6 to 6, or 8 to 8, or 2 to 2, or 10,000 to 10,000. All right, so we did that problem, and that was the empirical formula. That's what we came up with, CH. Well, now, this problem is, now I'm telling you, well, the actual molecular mass is 78 grams, okay? That is this, the molar mass. This is the number 2, okay? So what do? So I gave you the formula. I said it's the molar mass, so it's 78, divided by the mass of the empirical formula. So what's the mass of the empirical formula? Well, carbon weighs 12.01 grams and hydrogen weighs 1.01 grams. So we get 13.02 grams. So divide it by 13.02 grams and you will get 6. In this case, you can round. Notice that they get 5.99. Let me see what happens because I used a different molecular weight. I used the ones off of our table, 13.02. I get, yeah, 5.9907. Okay, basically it's 6. So what does that mean? That means that my formula, my CH, is 6 times the size than the empirical. The molecular formula, let me repeat it, the molecular formula is 6 times the size of the empirical formula, okay? So if I multiply everything by 6, so I have to multiply this number by 6, there's a 1 there and a 1 there, and this number by 6. So I get C6H6. That is the molecular formula, okay? So that's how you do molecular formulas. It's just a little bit additional math. You're finding the ratio of the mass of the empirical formula compared to the mass of the actual formula. Okay? So here's a problem that goes through the whole entire thing. All right? So you have some compound that has nitrogen and oxygen in it. Okay? And I'm trying to figure these out for both my empirical formula and my molecular formula. I'll just put E and M. So the empirical part we know. 30.45 grams, and I'm going to multiply it. 1 mole of nitrogen weighs, let me get my periodic table here. I'm going to do this out so you can follow it, 14.007 grams. All right, let me get this answer. I'm going to do it to kind of show you how I want to do it. Instead of letting the publisher do it, like I said, I don't totally like how they do it, but it's good to see that there is more than one way. 2.173913. Like I said, I like to use as many numbers as possible. Then we have 69.55 grams times oxygen. 1 mole of oxygen is 15.999 according to our periodic table. I want to use the exact numbers because I'm trying to get as close to these numbers as possible. I get 4.34715. Okay? So now I divide by the smaller of the two numbers. That equals 1. and 2.1739. I can already tell that that equals 2, but let's just do it on the calculator. Divided by 2.173913. I get exactly 1.9996. I can round it up to 2. Okay, I don't have to worry about multiplying these because these came out to be whole numbers. None of them is a 0.5 or a 0.25 or a 0.33. They're actual numbers. So my empirical formula is NO2. Okay? Now, the molecular formula, I have to use the mass, the actual mass, which is 92, divided by the mass of the empirical formula. Well, my empirical formula is 14.007 plus 15.999 plus 15.999. How do I get that? Well, nitrogen, there's one nitrogen, weighs 14, and there are two oxygens, 15.999. So 14.007 plus 15.999 plus 15.999. Sorry about that. I get 46.005. So divide 92 by 46.005, and we get 92 divided by. I can already tell you it's going to be 2, but we all love using calculators. The answer is 2. So that means my molecular formula is twice the size of my empirical formula. So the molecular formula is N2O4. Okay? This is how I want you to know this. It's not that difficult. As long as you know all of the steps, you should have no problem doing these. It seems like it's a lot of math, but first of all we're doing is converting to moles. We learned how to convert to moles from last chapter. Okay? It was pretty straightforward. All right? So we have moles here and we have moles here. We got empirical formula. Then I compared the mass, the total mass, divided by the mass of the empirical formula and got a whole number. This will always be a whole number. And then that's what my molecular formula is. All right? So now this is going to be a lengthy page-by-page turner of exactly what we just did. All right? This is exactly what we just did. Notice we got the same exact answer, N2O4. Okay? So that is it. I will post practice problems, or they will already be posted. Start doing these problems as fast as you can, guys, because there's a lot of math. The quicker you get this, the quicker you understand it, the better off you're going to be. All right? So I will see you in class.